Good evening, everyone. My name is Sylvester Ogunya, and a PhD student from the University of Ibadan. This evening, I am going to be showing us how to analyze data on the SPSS app. I have a collection of data here, and I'll be showing us how to um, update data on the SPSS app and using um, a statistical um, tool to analyze the data. So let's look at the data that we have here. A researcher collected the data attached to determine the influence of teacher experience on their pedagogical knowledge. 1, 2, 3, 4 represent the years of experience of teacher, 0 to 5, 6 to 10, 11 to 15, and 1 to 20 respectively. So having looked at this, we need to determine which of these. We're looking at two variables. That's teacher experience on one hand and the pedagogical knowledge of the teacher on the other hand. So we're looking at how we're going to be comparing how or the effect of teacher experience on their pedagogical knowledge. So we need to determine which of these variables is the independent variable and the dependent variable. I'm very certain that some of us wonder which is the dependent variable and which is the independent variable. Now, the dependent variable is the causal variable, and the dependent variable is the effect variable. So we would say that it is teacher's experience that is the independent variable, and we can put dv here. The IV here indicating independent variable, and the pedagogical knowledge will be our dependent variable. So having identified which is which, we are ready to analyze, or we're ready to pick up data to analyze. Of course, we have a set of data here classified into two. You can see the data, teacher experience and teachers content knowledge. About 100 participants in this research. So having done that, now let us move on to our SPSS. So on our SPSS app, we have two interfaces, the variable view and the data view. Where the variable view is where we actually label our variables. We do the labeling for our variables, and the data view is where we enter our data. So let us quickly label. We have two variables, the teacher content knowledge and teacher experience. So let us start with the teacher experience. Teacher experience. And then we need to attach values to them, because we have four groups and four categories. The first one is we can label 1 as teacher with experience 0 to 5. So in labeling 2, we can also we'll label 2 for teacher experience 6 to 10. We add it up. Then we label 3 for teacher experience 11 to 15. And the last group we label 4 for teacher experience 16 to 20. Now that is labeled, and then because we're talking about intervals, so our measure will definitely be ordinal. And then the other part is teachers knowledge, excuse me. That's content knowledge or pedagogical knowledge. Let's say pedagogical knowledge, pedagogical, pedagogical, pedagogy, and knowledge, so that we can use that as an identification. Because that is on a because the scores is a continuous um, variable. So we put it on scale because the values are continuous. So it has to be scale because they must have been they must have used some kind of achievement test to determine their um, pedagogical knowledge during the research. So because the data is continuous, then it is better we measure it as scale. Having described variables. So let us go to our data view to see, okay, fine, you can see that at the top we have teacher experience on one hand, and we have pedagogical knowledge on the other hand. We can also go further to really give further description to our variable view. So because we're talking about teacher content for clarity, teacher experience, because we won't be able to actually write everything in full in the naming column. Then this one is pedagogical knowledge. I can also decide to reduce the decimal places in my analysis. So I can reduce it to 0 because I don't want decimal positions in my data. So let's go back to the data view. So we can now impute our data. We can impute the data directly by entering the data value one by one. We can also import them if it is from an Excel file. We can even do simple copy and paste, just as I'm going to do right now. So let's just do simple copy and paste because that is easier and faster and because of time. So I could just copy teacher experience, the labeling 1, 2, 3 to actually determine the experience of teacher, which simply means that for those that we label 1, that means the experience is 0 to 5. Those label 2, the experience is 6 to 11. Those label 3, the experience is 6 to 10. Those label 3, the experience is 11 to 15, and those label 4, that means the experience is 16 to 20. So on my SPSS app, I can just simply copy and paste. So for the pedagogical knowledge as well, so like I said, it must have been some kind of achievement test or assessment test to test their knowledge must have been given. I would say that the values are continuous, and that's why we labeled it as scale on a variable view, because the value of the data is continuous. Value of the data is continuous, so I can simply copy and paste on my. Yes, now that we have a data set complete, yes, I think we have about 100. You might be wondering which statistical tool do we have to compare the mean of this data. All right, because we have two data, we can actually use t-test, but for the purpose of this lesson, we'll actually be looking at ANOVA. ANOVA. We'll be looking at ANOVA. We'll be looking at ANOVA. Yes, we'll be looking at ANOVA. We want to describe, we'll be able to quickly describe ANOVA and then analyze the given data we're using ANOVA and try to interpret our data at the end of the day. So what is ANOVA? ANOVA is analysis of variance. Is a statistical technique used to compare the mean of two or more groups. Now, very interesting. That obviously settles the assumption that ANOVA can also be used to compare the mean of two. Um, it is common knowledge that t-test is usually for the comparison of two groups. We can also use ANOVA to compare two groups, three groups, four groups, depending on our intention, on the purpose of the research. Its key assumption, the key assumption of ANOVA is that the data is normally distributed and the variances between groups are equal. It works by partitioning the total variation in the data into between group and within group variation, then comparing this variation using an F statistic. Having completed that, let's get back to our SPSS table. We have our data now, teacher experience, and pedagogical knowledge. So if you want to analyze using ANOVA, we'll go to analyze. We'll go to compare mean because that's exactly what we want to do. And these are options that we can use to compare the mean of our variables. And then, like I said, we have one t-test. We also have one-way ANOVA. So our focus will be on the one-way ANOVA. Now, that's a dialog opening up for us to analyze. So, which did we say was a dependent variable? We said that dependent variable was the content knowledge. That's a dependent variable. So we'll put it to the dependent list, and the teacher experience would form the teacher experience will be a dependent variable, which is a factor. So we'll move on to this. So what do we do? Let's look at options. Let's see what we have for options. Yes, we might want a descriptive the description of the statistics. We might also want to look at the homogeneity of variance. Normally, the homogeneity should have been checked even before we start our data analysis, but that's as it may, we can still check the homogeneity of variance from as we analyze data. So having done that now, what do we have? Yes, we can now say we now have a dependent variable and an independent variable. So we can go ahead to analyze our data. One way ANOVA is set. So if you look at the description, you can see from teacher experience 0 to 5, there were 43 of them who participated. 6 to 10, 36 of them. 11 to 15, 13 of them. 16 to 28, making a total number. And you can actually look at the mean difference for each and every one of them. The one with the highest mean at this point is 16 to 20 years, followed by 11 to 15, followed by 6 to 10, and the least mean difference is 0 to 5 years. So that's the description of our table. So we'll move on to test of homogeneity. We also did that too. Let's see. Of course, we know that 0 to it is all the participants, all the data actually pass the homogeneity test because all the groups actually are above 0.05, which means that um, it's not significant. And even that they are significant, then we would run into trouble with our analysis. So let's go straight to our ANOVA table. We look at that between groups, our F value is 12.3387, and the significant level is 0.005, which is less than 0.05 significant level, which means that our data is significant. That means the data is significant. That means that it is teacher experience and content knowledge. It's very key, which means that one, teacher experience tells a lot about the content knowledge or pedagogical knowledge of the teacher. But we probably might not be able to know which of these group 0 to 5, 0 to 6 to 11, and 6 to 10, 11 to 15, and 16 to 20, which of the group is really the major cause of this significant value. So let us, for us to be able to do that, we need what we called a post-hoc analysis. So we'll go back to our data sets, and then still on comparing, we're back to our ANOVA. We need to do a post-hoc. Post-hoc is like doing a post-mortem analysis of your data to know which of the group it's how the groups actually perform within the group, or how they interact, to know which particular group is responsible for the significant level of our eventual data. So we look at our postdoc and say, okay, of course, there are different options for this. I would rather pick Tukey and try Shefe too, to see which of them. Of course, they will all give. They are most likely going to give us the same results. But let's just look at the two of them and look at the post-hoc value that they bring to us. Okay, now that we have that, we can now analyze. Of course, from the post-hoc, we can now analyze and compare all the group. We can compare all the group. If you look at from Tukey's comparison, 0 to 5 compared to 6 to 10, it's significant. Compared to other group is very, very significant. But compared to other group, but from 6 years experience to 10 years experience is significant with 0 to 5, but against the other group, 11 to 15 and 16 to 15, it is not significant. It is not significant because what you have there is 0.865 and 0.675. And if you check the other group as well, 11 to 15, compared with other group, with 0 to 5, it is significant. With 6 to 10, 16 to 17, it is not significant. And then, of course, you move to the other one, 16 to 20 years. If you look at it from 0 to 5, it is significant, but with the other group, it is not significant. What does that tell us? As an analysis, if you look at Shefe too, in his own analysis, if you check through, it is basically the same, so that as they say, from the mouth of two witnesses, the truth is established. We've seen that both Tuki and Shefe have confirmed that they've confirmed the same thing, that it is the 0 to 5 experience that made the whole data set significant, which simply implies that as the teacher's experience grows, their pedagogical knowledge also increases. And from our data, we can easily interpret that the experience of teachers, the experience of teachers go a long way to determine their content or pedagogical knowledge. Thank you very much. I hope you have learned one or two things from this teaching. I will see you for more analysis. Thank you.